All right, we're going to solve a mystery number puzzle. And this one starts out like this. Clue 1. My number is a multiple of 2. Well, that's an infinite set of numbers, so we can't really do much with it, but we'll just file it away in our heads. Clue 2. My number has 7 as a factor. Okay, well that means it's a multiple of 7. And it's a multiple of 2. So we know now it is a multiple of 7 and 2. Now, here's where I might just rewrite that. So my number is a multiple of 14. Okay, but also still an infinite set. My number is less than 100, but greater than 50. All right, now we're getting some traction because we've entered finite set here. And so I can say between 50 and 100. So we can list these out, okay? And these are also even multiples of 7. Only because I know my multiples of 7, but I don't really know my multiples of 14 so well. So the first one above 50 is 56. The next one is not 63, but 70. And then the next one is not 77, but 84. And the next one is not 91, but 98. So these are the even multiples of 7 between 50 and 100. All right, so could be any of these. My number is the product of 3 different primes. Okay, so that means its prime factorization has 3 different numbers. So we just do the prime factorization of each of these numbers. 56 is 7 times 8, which means it is 2 times 2 times 2 times 7. Well, that's 4, so that's not going to work. 70 is 2 times 10, 5 times 7. Well, that does work, but we're not done. We have to see if any of these others work, and we have to prove that they don't work. 84 is 6 times 14, so that's 2 times 3 times 2 times 7. So that's 4 prime factors, so that doesn't work either. And 98 is 7 times 14, or 2 times 2, times 7 times 7. That also has 3 factors, but they are not different. These two 7s are the same. So the only one that works is 70. So now we've done the math, but now we have to explain it. So we have to say the only number with that, let's say, that is the product of 3 different primes is 70. Period. The only product, and then I guess we could just wrap up by answering all these other clues too. This is a multiple of 2 and 7. This is maybe also a multiple of 2 and 7. This is also the only number that is a multiple of 2 and 7. All right, hold on. All right, this is also the only number. I'm just trying to word this, and this is interesting because, you know, wording this proof is pretty important. The only number that is the product of 3 different primes, yeah, so this first sentence doesn't really work because this first sentence isn't true. There are many numbers that are a product of 3 different primes. So we have to say the only number that is a multiple of 2 and 7 between 50 and 100 that is also the product of 3 different primes is 70. And we can get rid of this. And so this is what we've got. And let's just read that again because it took a little bit to do it. The only number that is a multiple of 2 and 7 between 50 and 100 that is also the product of 3 different primes is 70. And this is what we found out.